On today's show, China launches its most ambitious human space mission ever. Scientists warn deadly solar storms could threaten astronauts heading to the moon. And astronomers may have solved the mystery of black holes that shouldn't even exist. Hi, I'm Jamie, and welcome to What's Happening in Space. China has officially launched what could become one of the most important missions in the country's space history. On May 24th, the Hangzhou 23 spacecraft blasted into orbit from the Zhouzhen Satellite Launch Center aboard a Long March 2F rocket, carrying 3 astronauts to the Tiangong space station. But this mission is very different from previous flights. For the first time, China plans for one of the crew members to remain in orbit for an entire year, a huge leap forward in long-duration human spaceflight capability. The crew includes Commander Zhu Yangzhu, pilot Zhang Zhu Yuan, and payload specialist Lai Kangying, who has become the first astronaut from Hong Kong to participate in China's space station program. Chinese state media say the mission will focus heavily on medical and biological experiments designed to help China prepare for future lunar missions and eventually permanent operations beyond low Earth orbit. The year-long mission will allow scientists to study how prolonged exposure to microgravity affects the human body, including muscle loss, bone density reduction, radiation exposure, immune system changes, and psychological stress. And this mission is about far more than science. China is aggressively expanding its space ambitions. The country has already confirmed plans to land astronauts on the moon before 2030 and is working alongside Russia on proposals for a permanent lunar research station expected sometime in the 2030s. Meanwhile, NASA's Artemis program continues to face delays, meaning the race back to the moon is becoming increasingly competitive. Many analysts now believe the next decade could see a full-scale geopolitical competition unfold on the lunar surface. But as China pushes farther into space, scientists are warning that the greatest threat to future astronauts may come from the star at the centre of our own solar system. Scientists are now warning that one of the biggest dangers facing astronauts returning to the moon may not be mechanical failure, oxygen shortages, or even micrometeorites, but the sun itself. The concern centres around solar cycle 25, the current 11-year cycle of solar activity that is now approaching its peak. During this phase, the sun becomes increasingly unstable, producing more sunspots, powerful solar flares, and massive eruptions known as coronal mass ejections. These eruptions launch billions of tons of superheated plasma and highly energetic radiation into space at speeds reaching several million kilometres per hour. When these solar storms strike Earth, they can create auroras and disrupt satellites, communication systems, GPS networks, and even electrical power grids. But for astronauts travelling beyond Earth's orbit, the threat becomes far more serious. Unlike crews aboard the International Space Station, future Artemis astronauts heading towards the moon will spend long periods outside the Earth's magnetic field, the invisible shield that normally protects our planet from dangerous cosmic radiation. Without that protection, astronauts could be directly exposed to solar energetic particles capable of penetrating spacecraft hulls and damaging human tissue at the cellular level. Researchers say prolonged exposure can increase cancer risk, damage the nervous system, and weaken the immune system, also potentially affecting cognition and decision-making during critical mission operations. And in the event of an extreme solar particle storm, the danger could become immediate. Scientists studying historical solar superflares warn that a sufficiently powerful eruption occurring during a lunar mission could expose astronauts to radiation levels high enough to cause acute radiation sickness in a matter of hours. That possibility has forced NASA engineers to rethink spacecraft designed for the Artemis era. The agency is already investing heavily in advanced space weather forecasting systems designed to monitor solar activity in real time. NASA and the ESA scientists are also studying improved radiation shielding materials, hydrogen-rich protective barriers, and even water-based shielding systems that could absorb high-energy particles. Future spacecraft may also include specially protected storm shelters, compact shielded compartments where astronauts could temporarily take refuge during major solar events. The issue becomes even more important as missions grow longer. NASA's Artemis 3 mission aims to return astronauts to the lunar surface later this decade, but future plans involve permanent lunar habitats and eventually crewed missions to Mars, journeys that would expose astronauts to deep space radiation for months or even years at a time. Some experts now believe radiation exposure may become one of the single biggest limiting factors for human exploration of deep space, and this is not merely theoretical. In May 2024, the largest solar storm in more than 20 years slammed into Earth, causing satellite disruptions and producing auroras visible far beyond the normal range. Scientists say it served as a reminder of how powerful the sun can become during peak activity. Now researchers are racing to ensure humanity is prepared before astronauts venture deeper into space than ever before. And while the sun threatens humanity's future in space, astronomers are uncovering mysteries far deeper in the universe, including black holes that may rewrite the laws of physics. Astronomers may have finally solved one of the strangest mysteries in modern astrophysics, the existence of black holes that, according to long-standing theories, should not exist at all. The discovery comes from new research analysing data gathered by the International LIGO-Virgo-CaGRA collaboration, a network of gravitational wave observatories designed to detect tiny ripples in space-time caused by violent cosmic events. These ripples, known as gravitational waves, were first directly detected in 2015, a discovery so important it later earned the Nobel Prize in Physics. Since then, scientists have detected more than 150 black hole merger events across the universe. But hidden inside that data was a major problem. Several of the black holes being detected appeared far too massive to exist according to standard models of stellar evolution. To understand why, astronomers point to something called the pair instability mass gap. According to current theories, stars within a certain mass range become so energetic near the end of their lives that high-energy gamma rays inside the stars spontaneously transform into matter and antimatter particles, specifically electron-positron pairs. That process destabilizes the star and triggers a catastrophic explosion known as a pair instability supernova. The explosion is so violent that the star completely destroys itself, leaving nothing behind. Because of this, astronomers believe black holes between roughly 50 and 130 solar masses simply could not form naturally. But gravitational wave observatories kept detecting black holes inside this supposedly forbidden zone, and the mystery only deepened as more detections arrived. One of the key papers addressing the mystery was published in Nature on April 23, 2026, under the title Evidence of the Pair Instability Gap from Black Hole Masses. Another major paper published in May 2026 analysed the latest GWTC4 gravitational wave catalogue and found strong evidence supporting this repeated merger scenario. Scientists now believe dense stellar environments like globular clusters may act as gigantic black hole factories, where repeated mergers occur frequently over cosmic timescales. The findings could dramatically reshape our understanding of how black holes evolve across the universe. It may also help explain another enormous mystery: how supermassive black holes become so huge so early in cosmic history. Astronomers have discovered gigantic black holes already existing less than 1 billion years after the Big Bang, far earlier than many models predicted should be possible. Repeated merger chains may finally provide an explanation. And perhaps most remarkably of all, scientists are learning this not through visible light, but by measuring distortions in space-time itself. Each gravitational wave detection is effectively the universe sending us a signal from some of the most violent and energetic events ever observed. Collisions occurring billions of light years away are literally causing measurable vibrations here on Earth. And there you have it. From China's growing ambitions in orbit, to the dangerous reality of solar storms threatening future moon missions, to black holes that may be rewriting our understanding of physics itself. Today's stories show that humanity is entering a new era of space exploration and discovery, one filled with both incredible opportunity and extraordinary challenges. Thanks for watching today's news clip. Remember to like and subscribe for more news updates, and we'll catch you in the next show.